Hello everyone. In this video we are going to see about consolidation. Consolidation is nothing but it is decrease in water content of saturated soil takes place because of the expulsion of water from the voids of the soil is known as consolidation. In other words, consolidation may be defined as compression of the soil under static load is called consolidation. The compressibility behavior of cohesionless and cohesive soil are not one and the same. A static load on a cohesionless soil may compress the soil immediately, but the same load on a cohesive soil may compress the soil very slowly. The compression consists of three broad categories, namely elastic or immediate compression, primary compression, and secondary compression. Elastic compression means it is an immediate and it is due to an elastic bending and a reorientation of the soil particles. In primary compression means it is due to volume changes of soil mass. Therefore, the compressibility of the soil is defined as the decrease in volume per unit increase of pressure. Next we are going to see spring analogy. Spring analogy is nothing but it is a mechanical model and it is used to understood the compressibility of the soils. Next we are going to see swelling index. Swelling index, the formula for swelling index CS equal to EI minus EF divided by log PI minus log PF, where EI is the void ratio corresponding to the effective stress PI and EF is the void ratio corresponding to the effective stress PF. Next we are going to see the compression index. The compression index CC is defined as the slope of the linear portion of the curve drawn down between effective stress and the void ratio. It is a dimensionless parameter. The formula for compression index CC is equal to E0 minus E1 divided by log 10 to the power of P1 divided by P0, where E0 equal to void ratio corresponding to the effective stress P0 and E1 equal to void ratio corresponding to the effective stress P1. And also the CC can be determined from the following equations. For undisturbed soil sample means the compression index CC equal to 0.09 WL minus 10. For remodeled sample means the compression index CC equal to 0.007 WL minus 10, where WL is the liquid limit of the soil in percentage. The compression index for undisturbed or field sample means that's equal to 1.3 cc of remolded sample. And also the expression for organic soils and peats in terms of in situ water content is as given below. The compression index CC equal to 0.0115 Wn, where Wn is equal to natural water content. Next we are going to see the compression ratio, which is also a compressibility parameter and it is defined as CR. Therefore the formula for CR equal to CC divided by 1 plus E0. Next we are going to see the coefficient of compressibility AV. It is nothing but the change in volume of soil per unit increase in the pressure, where AV is equal to minus del V divided by del P. The negative sign indicates that with increase in pressure there is a decrease in volume. Therefore the AV is also defined as secant slope of the effective stress and void ratio curve. Therefore the AV is equal to minus del E divided by del P. Next we are going to see the coefficient of volume change MV. It is nothing but the change in volume of soil per unit initial volume due to unit increase in pressure. It is also called coefficient of volume compressibility or modulus of volume compressibility. Therefore the coefficient of volume change or modulus of volume change or coefficient of volume compressibility MV is equal to del E divided by 1 plus E0 into 1 by del P. We already know AV is equal to minus del V divided by del P, and again the coefficient of volume change MV is equal to AV divided by 1 plus E naught. And also it is defined as the compression of the soil layer per unit original thickness due to a given unit increase in pressure. Next we are going to see the consolidation settlement SC or del H. The formula for SC or del H is equal to del E divided by 1 plus E naught into H. The coefficient of consolidation CV is equal to K into 1 plus E divided by AV into gamma W. Next we are going to see degree of consolidation UZ. It is nothing but the ratio expressed as a percentage of amount of consolidation at a given time within a soil mass to the total amount of consolidation obtainable under a given stress condition. The formula for degree of consolidation U is equal to E naught minus Et divided by E naught minus Ef, or P minus P naught divided by Pf minus P naught, or 1 minus U divided by Ui, where Ef is the void ratio at the end of consolidation. Et is equal to void ratio during consolidation at time t. E naught equal to void ratio at the start of consolidation. P is equal to effective stress at the time P. P naught equal to pressure at starting of consolidation. Pf equal to pressure at the end of consolidation. U equal to pore pressure excess at time T. Ui equal to pore pressure excess at the start of consolidation. Next we are going to see the degree of consolidation or percentage settlement, that is S divided by SF equal to 1 minus U into Ui, where S is equal to settlement completed at any time t and SF equal to final settlement at 100% consolidation. Next we are going to see the time factor TV. It is a dimensional constant and it is defined by the equation of TV is equal to CVT divided by D square, where CV is equal to coefficient of consolidation and T is equal to time, it is a variable one, and D is a drainage path. For double drainage, the drainage path is equal to half of the thickness. And also the time factor TV for different percentage of consolidation can be obtained by the following equation, where U is equal to less than or equal to 60% means that TV is equal to pi by 4 into U divided by 100 the whole square, where U is greater than 60% means the TV is equal to minus 0.933 log 10 to the power of 1 minus U divided by 100 minus 0.0851. Next we are going to see the determination of coefficient of consolidation. The coefficient of consolidation can be determined by curve fitting methods. Mainly there are two methods are used, namely square root time fitting method and logarithm of time fitting method. Next we are going to see normally consolidated soil. It is nothing but if a soil has never been subjected to an effective pressure greater than the existing overburden pressure and which is completely consolidated by the existing overburden pressure is said to be normally consolidated. Next we will see over consolidated soils. It is nothing but if a soil layer has been subjected in the past to a pressure more than the present overburden pressure and it is said to be over consolidated. Over consolidation might be due to the weight of an ice sheet or glacier which has melted away or by the geological overburden and the structural loads which has no longer exist now. The over consolidation ratio OCR is defined as OCR is ratio of pre-consolidation pressure to present effective overburden pressure. The formula for OCR is equal to pre-consolidation pressure PC divided by present effective overburden stress P naught. Next we are going to see under consolidated soils. It is nothing but a soil which is not fully consolidated under the existing overburden pressure is called an under consolidated soil. Thanks for watching this video. Please subscribe our channel for more videos like this. Thank you.